how do we calculate the amount of work done during a thermodynamic process? You may recall we learned that work is equal to pressure multiplied by the change in volume when the process is isobaric. Okay, so if there's a constant pressure, we can use this equation. So let's look at this graph over here. Okay, in this graph we've got pressure and it's constant. Okay, what's happening though is the arrow is telling us over time which way we're going. So we're going to the right over time, which means our volume starts here and ends there. Okay, so here if I take the pressure and I multiply it by the change in volume, what I'm getting is the area under the curve. Okay, so work is equal to area under the curve, between the line and the x-axis. Okay, so this works for isobaric, the equation. The general idea that work is the area under the curve works even when it's not isobaric, when the process has a pressure that changes. So for example, down here we've got the pressure is increasing. Again, we know it's increasing because the arrow is going up to the right. Okay, if the arrow were pointing the other direction, we'd start here. If you started up here and went down, then the pressure would be decreasing. Okay, so the arrow is just telling us what's happening. The volume's increasing, the pressure's increasing over time. Okay, now we can still say that that work is the area under the curve. Work is the area under the curve in this picture, then we have to figure out what that area is. Now, if you're in calculus, you might realize that the area under the curve is an integration. In this physics class, we're going to stick to algebra and geometry. Okay, so we're going to look at the area under the curve as some shapes here. Now, this is a trapezoid, and if you recall the formula for the area of a trapezoid from your geometry class, excellent. If you do not, then go ahead and break it into a couple pieces. Okay, this top part is a triangle, so we could find the area of the triangle, which is 1/2 the base times the height. And then the bottom part is a rectangle. Okay, so we could find the area of the rectangle, which is just base times height. And then after we find both of those, we add them together to get the whole area. Okay, and that area is going to be the work. Now, if we want to measure work in joules, then we must make sure that when we're talking about pressure, we are using pascals, and when we're talking about volume, we are using cubic meters. Okay? Again, to just kind of reiterate this arrow, because it's a different type of idea for many of us, okay? The arrow tells us what's happening over time. So over time, we start at a low volume and a lower pressure, and it goes up. Okay? So pressure and volume increase. If that arrow had been pointing this direction, then we would know that over time we start with a large volume and a large pressure, and that decreased. What this means, when we go to the right, we are going to have positive work done, and when we go to the left, there is negative work done. So we say positive work occurs when the volume increases. So up here, arrow is pointing this way. We start here, we end here, volume's increasing. That's positive work. Okay? Similarly, negative work occurs when the volume decreases. So in my second example down here, the volume started high, ended low. This would be negative work. Okay? And the arrow is always going to be telling you which direction that things are moving over time.